Joseph and Karis and Katie and Nicole and Sean. Good to see you guys. Hey, Kim. Okay. Glad to see you guys. All right, let's get started. I think people will trickle in as we go. So. All right, so this is the beloved class 8. Today we're talking about statistics and data interpretation. So as you guys see here, this is our last Thursday together, and I'm sad. But let's start out with some general housekeeping and see how you guys have been doing. Hopefully you guys remember from our first class that I encouraged you all to take a practice test. And if you couldn't take one at the beginning, I have periodically throughout our course of lessons encouraged you all to go ahead and take a practice test. So I know actually this isn't the first time you've heard me say this. So I want to see how many of you guys have taken your practice test and how many of you guys have not within the 4 weeks of this class. I cannot see who said what, so please be honest. It's just a poll. I'm not going to come down on you either way. Okay. Most of us, okay, all of us have responded. Most of us were honest. And only 30% of you guys have done a practice test. What? Okay, so if that's the case, it's fine. I'm a little disappointed, but I'll forgive you guys if you promise that after this course, sometime this weekend, or at least within a week, that you'll take a practice test, okay? Because you really need to see how this class has improved you, some things that you might need to still focus on, just to see kind of what is the difference and have you seen any improvement from doing your lessons, your homework, and coming to class twice a week. Okay, I hope the answer is yes. But the only way you'll know that is if you take a practice test. So please go ahead, take a practice test sometime really, really soon so it's fresh on your mind, and let's see how you guys do. Okay. All right, now that that's over, let's dig into the whole point of today's lesson, which is statistics and data interpretation. So our goals for today are to review the major statistic topics, explore how these topics are tested in GRE data interpretation texts. We'll talk about continuing to learn and practice the GRE math strategies, and that's it for our goals. All right, so statistics and data interpretation. So statistic questions on the GRE are really going to focus around really basic statistics. I don't know if any of you all were like this, but I took statistics my freshman year in college, and I'm really good at math. And that class kicked my hiney. I mean, it just was hard. It was a whole bunch of stuff. So a lot of complicated concepts, in my opinion. So I am not a statistics gal by any means. Unfortunately, not moving in baby. You like stats more than calc. I guess if I had to pick between the two, honestly, I might pick calculus. I'm a weirdo. I don't know. I just didn't like statistics. I know, it's just a little weird. I know, I get it. But I'll say all that to say, we're not going to get anywhere near that level of complication on the statistics that you'll find on the GRE. It's going to center around basic concepts. So that's the whole point here. mean, median, mode, range, weighted averages, standard deviation. And even with standard deviation, you don't have to calculate it. It's usually a comparison. And then some basic probability. For data interpretation, you guys have probably seen this. You'll see a graph of some sort, and then it will follow with 2 or 3 questions related to those graphics. So we'll talk about how to approach both types of questions today. All right, let's dig into some statistics. So mean, median, mode, and range. So the mean is basically the average. It's you often might hear it called the arithmetic mean or the average, right? So the average is basically the sum of everything in your set divided by the number of items in that set. And that's how you get the average. The median is different, and you have to be careful because a lot of people get mean and median mixed up. They are not the same. Okay, so median is the middle value in a set of numbers when those numbers are arranged in order from highest to lowest or from lowest to highest, which is most commonly seen. So be careful with that. Then you have mode, and your mode is the most common value in your set. So let's say you have, 3 ones in a set, 5 twos in a set, a 3, a 4, a 10, and 1,000. I think I said twos would be the most. 5 twos in a set, I think I said. Anyway, whatever number comes up more frequently in the set would then be your mode. And last but not least, you have your range, which is your largest value and your smallest value. And then you subtract the smallest value from the largest value, and that gives you your range. So I hope that was just a general overview and that wasn't something that was new to you guys. I think the main thing students ever mess up on, if they mess up, is forgetting the difference between mean and median. So just be careful with that if that happens to be something you happen to forget often. All right, let's do a quick practice question just to make sure you guys understand median, mean, mode, and range. So what is the median of 11, 11, 13, and 29? All right, 9 of you have answered. So I'm going to go ahead and close the poll and share the results. Most of you guys thought it was B, 12. And let's talk about why that's right. So something we didn't talk about in that slide before, mostly because I wanted to just see if that was something you guys already had the skill set of knowing, is whenever you are looking at the median, it has to be an odd number of numbers in the set for it to only be one number that is your median. And what do you do when you have a set of numbers that has an even number of values in it? How do you find the median then? Yeah, there you go. So you average the 2 in the middle. So if you have 11, 11, 13, and 29, we have 4 values here. So we have to take our 2 middle values and get the average of the 2. So 11 plus 13 is 24 divided by 2, which gives you 12. So the correct answer here is 12. Okay. So that means that maybe some of us need to do a little bit of reviewing, or maybe perhaps you just kind of got a little lost, or you just kind of read it too quickly. That's fine too. But if you didn't know that you need to take the average of the 2 numbers in the middle, I highly recommend that you all spend a little bit of time refreshing that concept in your practice questions for homework. So again, kind of looking back at the same example, if you had 11, 13, and 29, then the few of you, or the couple of you, I think it was 3 or 4 of you guys who thought it might have been 13, then it would be 13 because you have an odd number here. So you can just take the number in the middle. Okay. So just keep that in mind because the test will trick you or try to trick you on that concept. All right, so we have our first example question here. It says set D contains numbers 2, 5, 8, 10, 13, and 15. If the odd integer x is added to D such that the range of the set increases by 2, then what is the median of D after x is added? All right, so somebody tell me how you find range. Nobody? There you go. The biggest value minus the smallest value. So in our original set D, right, this is our set. In our original set, what would the median be? What would the range be? What would the range of this set be? $13, good. Because 5 minus 2, right? Biggest number versus minus smallest number is 13, okay? But we can't stop there because our question gives us a little bit more detail. It tells us that X was added to this set. And when X is added to the set, that the range decreases by 2. So what are the 2 places that I could put X to where it would impact the range of this set? There are only 2 places. At the end, so I could say maybe X could go here, or where? Or the beginning, which means X could go here, right? So at this point, we're not sure. X is either going to be on this side of our set or on this side of our set. But remember, it causes the range of the set to increase by 2, right? So that means our new range must be 15, right? So that's what we're looking for, a range of 15. And the only way that we can get a range of 15 if X is going to be on the, change this to black. Hard to see down here. All right, the only way to get my range to be 15 if X is on the far left side is if X is 0. Does everyone see that? Because if X is 0, then I can say 15 minus 0 is 15, right? But why do I know X can't be 0? Why do I know that this is not correct? Anyone see? Look back at, okay, it's not what kind of integer? Yeah. Right? Good. So we know it can't be 0. The only other option then is X is on the right side of our formula, meaning that X would have to equal 17. I'm sorry, yeah, 17, right? Because 17 minus 2 equals 15. Wait. Yes, 17 minus 2 equals 15. So then what is the median after D, median of D after X has been added? So if X is added on that end, 2, 5, 8, 10, 13, 15, and 17, you guys tell me what our new median is. Okay, what is our new median? those of us still working. Okay. I'm gonna go ahead and end the poll. And I've got some questions in the chat. So if I don't answer the question, let me know. Yes. To the person asking me a question in the chat, the answer to that is yes. But we'll look at it together. Most of us got that 10 was the median, right? Because 10 is in the middle. In this case, we don't have to take an average because we have an odd number of numbers, and that makes 3 on the right and 3 on the left. I'm sorry, the left and 3 on the right. So 10 is our number in the middle. That makes 10 our answer. And just to make sure everyone understands why 17 works here, or why x has to be 17, remember, x can only go on the left or the right. So when we say, okay, well, it can't go on the left because x can't equal 0, then our original set is 2, 5, 8, 10, 13, 15, and x, right? And we know that we want our new median, we want our new range to be 15. So technically what I'm saying here is x minus 2 must equal 15. X, largest number, 2, smallest number. And then I just kind of combine those steps here. X equals 17. Okay. All right. We'll keep it moving. And we'll come back to this specific question later. Okay. Weighted averages. So this is the concept that values that appear more frequently or greater in volume have more weight on the average, right? So think about it like this. If you have an athlete that scores 30 points in their first 4 games and then 10 points in her 5th game, how many points does she score per game? Do you all think the average, so let's say that there's 2 sets of numbers here, right? There's 30 and there's 10. So the average between 30 and 10 is 20, right? So if there was only 2 games and 1 game she scored 30 points and 1 game she scored 10 points, then the average would be 20. But we know that not to be the case. We know that her first 4 games, she scored 30 points, and her 5th game, she scored 10 points. Do you all think the new average or the actual average of the games is going to be higher than 20, equal to 20, or less than 20? What do you guys think? Less than 20? Okay, that's a good guess. Higher than 20? Okay, that's a good guess. Greater than 20? Less, because it'll be spread out. Okay, I like the reasoning. Okay, let's think about it like this. If we had a van, okay, I don't know if any of you guys had this experience, but I grew up going to church, and they call it a church van because we always go to different vacation Bible schools and different events and summer camps, okay? So whenever I hear the word big van, I always think about a church van. But I digress, right? You've got this van, this big 18-passenger van. What do you think would be heavier? A van with 12 5-year-olds and 2 adults, or a van with 12 adults and 2 5-year-olds? What would be heavier? Yeah, the van with more adults. Why? Because it's heavier, right? And so the concept of weighted averages is that the more higher numbers you have, for example, in a set, the more that the average is going to lean towards those higher numbers. And if you have more smaller numbers in the set, then the further that your average is going to lean towards those smaller numbers. So in this example, what you technically have is 30 4 30s, right? So in this case, 4 adults, right? And then the fifth game is 1 game and 1 child. Does everybody see that in that analogy? Okay, so what that means is your average is going to lean heavier towards the bigger number in the pack. And so since the average of 10 and 30 is 20, your average of higher numbers is going to drive up your average above 20, okay? And so because of that, you often can use this logic to work through problems without ever having to do them. Because you start to recognize, okay, well, it's going to lean this way or it's going to lean that way. So I know I can eliminate certain answer choices, or I can actually find my answer without ever having to do much math at all. Okay, so let's look at this example here and let's see if you guys can figure it out. Okay, we'll work through it together, but just in case, let's see how you guys do. All right, guys, take about 10 to 20 more seconds before we wrap it up. If you're not sure, just do me a favor and guess. Okay. Just throw something out there. All right. I'm gonna go ahead and close the poll. Most of you guys were able to answer the question. I'm actually proud of you all. 7 of us got E and 3 of us got B. So I'm really glad that we can at least rule out these 3. And I'm glad that you recognized your numerator. Either way, you recognized your numerator. Where some people got tripped up is our denominator. And this is a common mistake. Remember, average is the sum of all divided by the number of items, right? So the number of items isn't 10 years old and 11 years old. That's where you got the 10 plus 11 equals 21. That's not right, okay? Because that's not your quantity. That's not your number of variables in your set. Your number of variables in your set is your number of students, right? Which is X and Y. So that's why you got on your denominator X plus Y and not 21. That's a very common mistake, okay? So no worries there. Hopefully that all makes sense. All right, let's keep it moving. As I was talking about, sometimes with math and some of your statistics classes or questions, you will be able to use logic instead of a formula. In this particular question, we used a formula because clearly our answer choice is a formula. But you don't always have to do that. Sometimes you can figure out the answer to a question without using the formula. So for example, if it says something like twice as many of X than Y, then you know that your average is going to have to be as close to X, as close to X than Y, or closer to X than Y. If something says the average is 3 times as close to X than Y, then you know that it's going to be 3 times as many Y's than there are X's. Okay, and that can kind of help you decipher that and how to approach that, or like I said, rule out certain answer choices as wrong or certain answer choices as right without having to do any math. So once you kind of say, okay, well, I know that the average must be 2 times as much or 3 times as much, or I know there must be 2 times as many Y's as there are X's, then you can go through your answer choices or your quantities and, like I said, either choose the correct one or at least rule out ones you know don't fit. So don't calculate unless you need to, or unless that's just what comes naturally and most efficient to you. All right, so here we have another example question, and I'm going to challenge you guys to do this one on your own, okay? And if you do this the logical way, okay, meaning no math really, not much math at all, no calculation at all, you really should be able to answer this question in 45 seconds or less. I mean, super quick, read through it, think about it, and answer. But you can find the answer the long way too, okay? I just want to let you know that there's more than one way to answer this, and we will look at it together and look at both methods, especially because the logical way may not come so easily or so naturally. All right, most of you have had a chance to answer, but in case, oh, there we go. All right, I'll give maybe 10 more seconds just in case. 4, 3, 2, 1. Ding, ding, ding. All right, we're a little split. we're kind of not sure. So let me show you how I work this out logically, and then I'll show it to you mathematically. All right, so there are 3 sections of algebra at the school. You have section A, you have section B, and you have section C. And we know that section A has 20 students. And we know that B has 27 students. And we're told that C has 30 students. All right, and their average scores on exams are 90. I'm sorry, is that right? Yep, 90. I'm gonna put percent, so that just makes it easier to decipher. 80% for our section B students and 70% for our section C students. All right, so here's what I immediately notice. Which one of my sections has the most weight? Anybody know? Which section? C. Why, Katie? Why does C have the most weight? Yeah, it has the most students, right? So we know that C is gonna weigh our score more. And I also notice that C has the lowest test score, right? So what that means is, right, most amount of students, right? So what that means is, as I add students into this group A, B, and C, it's gonna weigh down closer to 70 because that is our biggest group of students. So without having to do any math, I feel confident enough to say, well, this is gonna be closer to 70, probably somewhere between 70 and 80, right? Somewhere in there, but definitely not more than 80 because here B is 80. So in order to be more than 80, I would have to have more students driving up our average above that. And there's only 20 students that are above 80 and more students that are above or below 80. So I can pretty confidently say that B, okay, quantity B is larger. Yes, combined you do, but you have to think about what the average is, right? So when you're looking at your students and you're looking at, the distribution of scores, you're gonna have a whole bunch of 90s over here, a whole bunch of 70s over here. And if you look at kind of the average in between these numbers, it's gonna hover around 80, okay? If you just had 1, 1, and 1, let's see, how would that be? 80, right? If I take 90 plus 80 plus 70, right? That gives me 240 divided by 3, which is 80. Yes, you would, Callie. That's 80. So the average, if they all had the same weight, would be 80. And you can't combine them together. You have to look at them separately. So if this average is 80, I have more students 30 students pulling more towards that 70 range than I do moving up above this average of 80. Okay. So even though, yes, combined, you have more students in that range, if you look at them in separate pockets, you notice that it's going to tilt the scale a little bit more to the right, away from it, down past 80. But let me just show that. Don't take my word for it. Let me show it to you mathematically, because quite honestly, that just might not have come naturally. Yes. And if 30 students were in the A section, it would have been the exact opposite. Okay, so that's how I kind of get my answer with guesstimation. And Callie already let me know that she knows how to go about this, but let's just kind of work on it together. So hopefully you remember this little formula thing that you guys did when you answered this question here, right? You said, okay, well, there's 10, the variable is 10, and there's X number of students. And then here you took 11, right, times Y, because literally what you're doing is saying 10, 10, 10, 10, 10, whatever, X number of times, right? So that's how that formula worked, right? So you're going to use that same principle for this question if you solve it mathematically. You're going to say, okay, well, there's 20 students in A, right? And there's 20 students in, I'm sorry, 27 students in B. And then there's 30 students in C. And I know these values here, right? So it's 70, I'm sorry, 90, that was the score here. It was 80, that was the score here. And it was 70, that was the score here. So 20 times 90 is 1800. And then you can plug 27 times 80 in your calculator, but I would just kind of do a little, like go back to second grade and say, okay, 8 times 7 is 56, carry the 5, 5 times 2 is 16, plus 5 is 21. Then I have to add my 0 back on. So this is 2160. And then 70 times 30 is 210. I'm sorry, 2100, not 210. Okay. And then you can add those all up together. You could line them up and add them together. You can put it in your calculator, whatever you want to do, but it's 60, 60, right? And then I can take that and divide it by the number of students in the group, which is 20 plus 27 plus 30. So 20 plus 27 equals 47 plus 37, I'm sorry, plus 30 equals 77. So this divided by 77, I can't do it in my head. I'd have to put it in my calculator, but I can tell you that it is 78.7. So the value of quantity A is 78.7, and the value of quantity B is 80. So I know that quantity B is a large quantity. Okay, 1 second. I have a question, guys. Let me read it. Yes, so Callie, that would be the average for the number of categories or sections. Yeah, that would not be the average per student. Yep, so you have to be careful there. No problem at all. All right. So as you can see there, you could do it logically, or you could have done it by the formula. Either way, it ends up working out. All right, let's keep moving. All right, we'll come back to this question and we're gonna move on to standard deviation. So with standard deviation, basically you're wanting to know how much do values in a set deviate from one another. So with that, the values that are farther apart, they're gonna have a bigger standard deviation. And you can kind of see this if you were to plot something on a number line. Change my pen color. Like if you were to plot something on a number line like this, right? If there's large space in between and the standard deviation is how much let's say this is value A, B, C, and D, then the deviation between these is going to be greater than in comparison if you had A, B, D, right? A, B, C, D. In this situation, the space between the values is smaller. So it's going to have a smaller standard deviation. The GRE will only, thank gosh, only ask you to compare standard deviation It's never going to ask you to calculate it. So what that means is going to give you maybe two sets of values and say, which has the bigger standard deviation or something of that nature. So rest assured that you won't have to go and pull out your handy dandy statistics class notebook and brush yourself up on how to actually calculate standard deviation. All right. The only exception is if there's a set with only one value, then there is no standard deviation because there's nothing to compare it to. Okay, so it will be 0. All right, so here we have a set, and we have set A and set B. And if we want to know which is bigger, the standard deviation of set A or the standard deviation of set B. Well, let's look at our number line example again. If this was 0.2, and this was 0.4, and this was 0.6, and this was 0.8. And if our set here was 2, 4, 6, 8, what's the bigger space? From here to here or from here to here? Yeah, this one, set B, right? Because there's more space number-wise numerically, right? 4 minus 2 is 2, right? Whereas the space here is technically 0.2, right? So this is the space, the standard deviation here is 10 times bigger than the standard deviation between the values here. And so here our answer would again be B. Okay. All right, let's see if you guys can work on this one by yourself, but I'll help get you started. Okay, so on a certain standardized test, the mean is 180. What is the mean? What is the mean of something? Another word is for the average, right? So that basically we have a set of numbers summed together, divided. Technically, it's not the median, but it's kind of a representation of visually, let's just say it's in the middle, okay? It's not always the case, but let's not get into semantics here. So our mean on our line is 180. And we know that our standard deviation is 35, right? Plus 35 and minus 35. See if that helps you with finding the answer to this specific question. Oh, I forgot. You can't answer this one because it's a multi-select. Never mind. So can you put your answers in the chat? Or give me one number that you know would work. Which of the following is within 2 standard deviations of the mean? Thank you, Sean. Okay. Thank you, Katie. Good. All right. So one of the numbers. Good. Okay. So I'm getting some good answers here. Let's talk about it. So 2 standard deviations would be 1, 2, right? 1, 2. Spacing, right? 1 and 2, 1 and 2. 150, that's a good one, right? So when I take 185 and I subtract 35, what do I get? I get 145, right? So immediately I know that within this, 150 is somewhere in here, right? So to someone's point, good, Sean, good. 150 works, yes? All right, to the left, I have 180 plus 35, right? That's just one standard deviation. So that gives me, doing it in my head, 215. So I know 200 is in here, right? If I go another standard deviation and I add another 35, That gives me 250, right? So I know 225 is in here, but 275 is too far, right? Because I've already gone 2 standard deviations over, where this is 250 and this is 215, right? 215, 215. I could do the same thing to the left, right? So I've already went 1 standard deviation over, but I didn't go another one. So my other one is 145 minus 35, which gives me 110, right? And that's higher than 100. So I know 100 won't work. And if 100 doesn't work, 75 doesn't work either. So my answers are C, D, and E. Okay. Those of you who sent me answers in the chat and didn't maybe get it right, hopefully that makes sense. If not, feel free to let me know, okay? Shoot me a message. Assuming that, oh, got chat. Okay, everyone's good. All right, so let's move on to probability, assuming that all of that makes sense so far with standard deviation, mean, median, mode, and range. Next step is probability. So all probability is what you want subtracted by, divided by your total. So as a proportion, probability can be expressed in maybe 3 different ways: fraction, ratio, and percent. So of course, a fraction would be like 1/2. A ratio would be like 1/2. And then percent, of course, would be like 50%. Okay, so those are 3 different ways you might see probability expressed. Okay, so here's an example question here. It says in a high school in a small town, there are 12 freshmen, 14 sophomores, 15 juniors, and 19 seniors. That's a really, really small town, right? If a student is selected at random, what is the probability that student will be a freshman? All right. So just getting a gauge on where you guys already are when it comes to probability. Let's see how you do. And again, as always, if you don't know or you're not sure, please don't be afraid to guess. Sometimes I'm waiting on you guys to answer and you may not, have an answer, and that's okay. Ooh, so far so good. Oh, good job, guys. Awesome. All right, I'm going to close the poll. I don't think we ever get to 11 people. I think someone might be hanging in the balance with us here. So 10 out of 11 of you guys answered it and everybody got it right. So I'm not even going to beat that horse. I'm just going to keep going because you guys got it. Totally makes sense. So I'm glad about that. All right, GRE strategy. And means to multiply or means add. So when you're looking at probability, harder probability questions are going to make you combine probabilities. So they're going to have you look at 2 different scenarios. This happens and then this happens. What do you do? So when you see that, look for clues in your question stem. All right. Also keep in mind that the total probability of anything happening is going to always be 100%, which is also 1. Okay. So just be careful of that and recognize that all of your different probabilities are always going to come together to equal 1. That's a principle that's tested often. And then the and or rule is also true for the rare counting permutation and combination problems. If you struggle with permutations and combinations, I'm going to be honest with you, most people do. don't spend a whole lot of time trying to like get up on that, because you'll be lucky if you get a handful of questions related to that type of question, permutations and combinations. So just don't focus too much on it, so much so that, you know, you get yourself worked up. It's not frequently tested on the GRE. So we're going to focus on what is heavily tested on the GRE. Okay, I have some little slides coming up to walk through this together, but I want to give you guys an opportunity to let me know what you would prefer. I know, I hate those two. I hate those two, Katie. So would you all want me to walk us through this together? Or do you all want to take a stab at it first and then we'll walk through it together? What's most helpful in this context? Try it first. Okay, Christina won because she responded first. All right, try. Everybody wants to try it first. I like that. Okay, so to my brave people who want to try, go ahead and do it. And then keep in mind that you guys can always shoot me a message in the chat if you have questions as you're working. All right, for those of us who are just not sure, if you're spinning your wheels, per usual, please go ahead and guess for me, so that I know that we can work on it together. Okay. I'm used to seeing 10 of you guys respond, so I like to see that it, there we go. Okay, like it, love it, love it. All right, so we're a little over, you know, kind of evenly distributed, but by an inch, C is the winner. So let's see who's right. All right. So let's think about it. It says a box contains 6 black balls and 4 white balls. If 2 are selected at random without replacement, what is the probability that both balls are white? Okay. So we have how many white balls? 4, right? So 1, 2, 3, 4. We have 6 black balls. 1, 2, 3, 4, 5, 6. So in total, we have 10 balls, right? So let's talk about our first pool, meaning our first selection. Remember, whenever you're looking at probability, it's always what you want over your total. So what do we want? We want white balls, right? So we want white balls divided by total balls. How many white balls do we have? 4. Yeah. And how many total balls do we have? So our fraction is 4/10. But we can't stop there. There's a second pool that happens, right? So in our second pool, we still have 10 balls, is that right? No, right? Because we already took out a ball. So that one white ball we already took out is gone. And now we have 9 balls. So is our ratio, is our probability still of getting a white ball still 4/10? No, it's 3/9, right? 3/9. So we have two values now. We have 4/10 and we have 3/9. And the question here is, what do we do with that? Well, remember, we want one white ball and another white ball. So that and means we multiply. So what is the probability of white ball 1 times the probability of white ball 2? Well, that's 4/10 times 3/9, right? Which equals 12/90. And that simplifies because 6 goes into both. So 6 goes into 12 2 times, and it goes into 90 15 times. Perhaps you didn't know that right off, but you might know that it goes into 3, right? So even if you said, okay, well, 3 goes into 12 4 times, and 3 goes into 90 30 times, then you could still get to your 12/15. Either way, right? Just an extra step. And that makes C the correct answer. So congratulations to my 4 people who chose C. And for those of us who didn't, no big deal. Hopefully now it makes sense. Okay, we'll come back to this question. But at this point, I want to pause and make sure that mean, median, mode, range, standard deviation, and probability all make sense. Did I lose anyone? And keep in mind, help@magoosh.com is always going to be there for you if you're like completely lost and you need that foundation. Definitely doing some more practice will help. But if you're lost, I do want to know. So let me know if everybody's okay. Thumbs up, smiley face, yes, no, woohoo, blah, something to give me some, I like that. Oh, I don't know, Katie, that could be good or bad. That could be a good one or a bad one. Good, getting there. Okay, Nicole. Okay, all right, I like that one too, Katie. But now I know how you really feel. All right. And for those of us who are kind of feeling like they're just getting there, most of us are, okay? So just continue to practice, and we'll go back to a couple of example questions to reinforce it. And if we have some time at the end, I can hang around for additional questions. Thank you, Sean. Good. All right, so let's talk about quant question structure. So you probably remember this from the practice test for those of you who took it, or the real GRE for those of you who have already taken it, or lesson 1 because we talked about it then. So in general, the structure for the GRE is going to be quantitative comparison. It's always going to be the first about 7 questions in a section. And then you'll have your multiple choice select one or more, your numeric entry, and all of these can appear in any any order in that specific section. But you're always going to have at least one data interpretation set in a section. It's never going to be in your quantitative analysis section, but we'll talk about that. I'm sorry, your quantitative comparison section, but we'll talk about that in a second. All right, so what is data interpretation? Like we talked about earlier, it's basically 3 questions that are grouped around a set of data, and it's usually some diagram, some graph, some bar chart of some sort, pie chart that you have to interpret. So the questions can be multiple choice. It can be select one or more multiple choice or numeric entry. And as I mentioned earlier, it will not be a QC question or a quantitative comparison question, but the questions will come in a row. So what you can deduce from that is that data interpretation questions will never be in that first 7 questions, okay? So how you approach a data interpretation question is very much like you would reading comprehension passages. So basically you're gonna do an initial skim, you're gonna summarize as you go, and then keyword skim for those specific questions. So it's literally just marking out passage and adding graphic strategy. So step number 1, do an initial skim. So skimming is not the same as every single data point, looking at it and interpreting it, okay? Making sure you understand, or make sure you understand that skim basically means you're trying to get the gist. What is the general information that I need? Set yourself up to pull those specific data points later on. And ways you know clues, like just finding those clues, is looking at the title. Look at the subtitles. Look at the units. What's being measured? What's being trended? Okay, so that initial review usually will help you. And looking at the trends and the legend and keys tells you what's being measured. So just that general getting the lay of the land. All right. Step 2, once you've gotten the lay of the land, you kind of understand, okay, this is what this passage is about, and this is what it's showing. Then you do a deeper dive, just a little bit layer, 1 layer, maybe 2 layers deeper. And in that case, you're going to summarize each graphic. You can jot it down on your scratch pad. This helps keep you honest and keeps you focused. And it allows you to reference all of that information for later. And when you're doing that, keep your summary really, really short and focus on the data trends, because oftentimes that's what you're going to be tested on, is trends, especially if you see something like this, oops, yep, my pen delayed, or right, that's telling you a trend. And you're welcome for the side effects or sound effects. So that's telling you a trend. And so you want to take note of that trend. Okay, focus on that information if it's available for you. All right, so some things you might summarize and some ways you might summarize, because it can be very time consuming to do that. So you can say saturation up as temp up. And I would even make this even shorter. I would say sat up, temp up, something like that. Okay, so you can make it even shorter. You might say something like most greater than 80%, or air quality definitions. Just something that kind of helps you orient yourself and know where to reference back in your review. So last but not least, step 3 is keyword skim for specific questions. So find the most specific words, numbers, whatever in a given question, because those are going to be key information. That's going to be key information. You can use your subtitles and units, your legend and everything like that to narrow in the most important information and only read that relevant data or review that relevant data. All right, so here we have some graphics, and immediately this is what I would do. Okay, so I have BMI and I have BMR. Okay, cool. 15 males between the age of 43 and 65. But if I look down here in my chart, right, I don't really see anything about age. So I'm figuring that's probably not that important. It might be, but I'm assuming it isn't because it has nothing to do with my chart on this side or on this side. I don't see anything about age either way. So that to me feels like a detail meant to throw me off. So I see there's a trend, and I notice as in general, right? Not all the way, but I notice as BMI goes up, so does BMR, right? So there seems to be a one-for-one, not one-for-one, but like a stacking relationship between the two. As one increases, the other increases as well, okay? And then I see my categories over here all relate to BMI and whether you're considered to be severely underweight or overweight. Okay, I get it, cool, right? So that's kind of how I would look at it, okay? I got the lay of the land. I know what everything means and where everything is, cool. All right, invest in time avoiding traps. And this is very similar as a test taking strategy that we talked about before. So investing time to avoid traps, take about 30 seconds to process the question stem. So you notice how I said, that age thing probably is just meant to throw me off, like make me feel like that's important. That's an example of just going through and making sure you're not falling for anything that could throw you off or something that's meant to distract you. Stop at your punctuations, interpret and identify the information you're given. Sometimes you might want to touch the graphic for each step. Just maybe adding that physical component can sometimes help you just reorient yourself and kind of going through and make sure you're like reading the line and understanding the information. Sometimes just touching it in general can really help, believe it or not. All right, invest time in avoiding traps. Still, take the last 5 seconds to check back. Make sure you're going back to your question stem and understanding, okay, what did they really ask me? What am I really trying to get to here? Did I answer the question right? Reread your question target and your answer. See if there's any traps there. Did I make that too easy, or was it just an easy question? Did I look at the right graphic? Was it the right year? That's another thing. Sometimes you'll have a graphic might look like this and it'll say like 2020 or 2020. Then it'll say 2021. And it'll say such and such happened in 2020. What was da-da-da-da-da? But then it'll give you the answer choice that would be right if you found that for 2021. Okay, again, evil, right? But that's why you have to be careful. Go back. Did I look at the right graphic? Did I calculate the right thing? Did I look at the right part of the graphic? Did I mix up any units? So just taking time, if you can, not a long time, just 5 or 10 seconds to go back. Okay, I looked at, they said, find the value of X, I found X. Okay, cool. They said 2021. Okay, cool. I found 2021. Okay, just taking that few seconds can really save you on test day. All right, so we're gonna work through this question, but I'm gonna let you guys do it yourself. So I'm gonna give you, it's kind of hard to see this on here. So this is really acting crazy. All right, down here, I have a link that I created where I kind of put this question on one Google Doc page, just because it's kind of hard to see it in pieces like this. Okay, it's a little difficult to see it in pieces like this. So I put the link there. Hopefully you guys can see it. Oh, I just sent it to Katie. Sorry. Katie's like, I see it. Everyone else is like, what are you talking about? Okay. All right. If you guys can see it, anybody who decides to click on it, you don't have to, but it's just so you can see the graphic and all the questions at once. Can you just give me like a yes or a no, a thumbs up, just so I know that you're able to see it? Oh, I'm getting some people requesting to see it. You should be able to see it without requesting. Okay. Hang tight, guys. I'll give you, I don't know why it's saying that. I'll give you permission. Share. 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 Yeah, guys, it shouldn't do this. I don't know why it is, but if it is asking you to request access, just go ahead and request it. I'm going on my phone now and granting all of you guys access. Yay. Awesome. Thanks, guys. Thanks for confirming. Oh, almost forgot about Allison. I didn't know we had an Allison. Okay. I think I've gotten all the requests granted. Okay. Let me know if not. Hopefully you guys all see it. If not, it really isn't a big deal. It's just, I thought it might be easier to see all the questions together. Okay. So hopefully you guys are in. If you're not, just look on my screen here. And as you know, we looked at the BMI, BMR, and we looked at our charts. So the very first question says, the trend line on the graph indicates for a given BMI what the expected BMI would be for that individual in this group, or for that individual in this group. How many individuals have a BMI higher than predicted by this trend line? Okay, so here's the trend line. All right, here's the trend line. Of course, it's not going to be a straight line because I can't do one to save my life, right? But it's telling me here, as we wrote before, BMI goes up, BMR goes up, right? So if this is the trend line, meaning this is the normal trend, or the, not even normal, that's not a good word, but the expected trend, right? Then the values above would be higher or lower than the expected trend. Yeah, higher. And the values below would be lower than the expected trend. So basically what they're saying is how many values are above the expected trend and how many values are below the expected trend. Okay, so think about it and tell me your answer in the chat. Good, Callie. Good, Christina. Good, Sean. Good, Katie. Good. Anybody unsure? So we can talk about it. If not, I'm going to assume you get it. But real quick, I can at least show you 1, 2, 3, 4, 5, 6, 7. That one's close, but it's not above the trend line. It's right below it. So that means there's 7 values above the trend line. So the answer here is 7. Good job, guys. All right. Let's see if you guys can do this one on your own. Most of you have answered. I'd love to see one more person answer. If you know it. Okay. All right. So here are our results. So let's talk briefly about it. It says the individual on this chart with the highest BMI. So I'm going to stop there. The individual on this chart with the highest BMI. What data point is the individual on this chart with the highest BMI? Well, BMI is here, right? And the data points represent BMI. So it's this data point way over here that has the highest BMI. And so what does it want to know about that point? Well, it wants to know what is their BMR approximately. Well, all I have to do is follow the trend line all the way over, and I see it's about 1700. So then I'm looking at my answer choices here, and I say, oh, okay, 1702 is the closest one. I think for those of us who thought it might have been 1853, you were looking for the opposite. So basically what you found is this point here. And that is the person with the highest BMR. Okay, so that's that one strategy, that one step about going back and saying, did I answer the question? If you circled this and you went over and you said, okay, it's about 1850, right? And you say, okay, well, let me look. So BMI, oh, wait, that's the highest BMR, not the highest BMI this way, okay? So sometimes it's taking just a second to look back and making sure that you don't get yourself tripped up on that fact. Okay. And we have one more question with this data set. Oh, you meant C? That's okay, Nicole. Totally okay. It happens. All right, so this question says, which BMI groups have representatives on this graph with a BMR greater than 1600 kilocalories, kcals per day? All right, so just looking at the question, hopefully you guys maybe see it on the Google Docs because I can't show you both at the same time, just a limited space. But hopefully you guys notice from the question here that I'm gonna have to use both charts, right? Because it starts introducing like the underweight categories and the overweight categories. So I know I'm gonna need this chart. And then it's talking about the number of, oops, yikes, I'm going all the way wrong, sorry. And then it's talking about the graph, BMI groups and BMR groups. So I know I'm gonna need the other one as well. Okay, so this is one that I'm gonna need you to tell me your answer in the chat. And if anybody did not get access to the Google Docs, I guess you'll have to let me know, which chart you need to see. I'll start here because your math needs to start here. But then if you need me to go over to the other slide, I can, or if you want to take a screenshot, I can. Good job, Christina. Good job, Kim. Good job, Sean. Good job, Callie. Good job, Sean. Which Sean is it that has the newborn? Almost, Janice, you forgot one. Oh, it's Joseph. I don't know why I thought it was Sean. I'm sorry. How's your baby? You can select multiple, yes. And Sean Calhoun and Sean Arters, I didn't mean to wish babies on you if you don't have them yet. I'm sorry. I don't know why I thought it was Sean. Oh, he's crying. Bless his heart. Right, one day, dreams of it later on down the line. Katie. Okay, is anybody still working? Because I can show you guys how I would approach this if not. Give me something in the next 10 seconds or I'm gonna go ahead and start looking at it. Okay. Yes, good job. All right, everybody who submitted one got it right. So I'm thinking you guys have a hang of it. Is anyone confused? I'm happy to go over it, but for those of us who got it right, I don't want to belabor the point. So again, 10 seconds to tell me if you'd like me to go over it. Okay, sure, no problem. All right, so it says, which BMI groups have representatives on this graph with BMRs greater than 1,600 calories? All right. So first I want to see which people have something greater than 1,600 calories. Which BMI groups? So first I recognize that if it's greater than 1,600 for BMI, I'm sorry, for BMR, why that little line went across there. Hold on. Again. So if it's greater than 1,600, then I know my cutoff is here, right? Everything above this. Okay. The next thing I notice is, well, all of the data points, all of the individuals that these data points represent that have a BMR greater than 1,600 are all in this quadrant here, right? Which means they all have a BMI greater than what? There you go, Katie. Good. They all have a BMI greater than 25. Okay. I'll tell you in just a second, Janice. You'll see it in just a second. Okay, so remember from the last slide, if they have a BMI greater than 1,600, then that means they also have a BMI greater than 25. And when I look at these categories, the only people who have BMIs greater than 25 are overweight and obese. So the answers are overweight and obese. All right. Makes sense? Okay, no problem. Good. No problem. My pleasure, guys. All right. So here we have another graph here, and I'm going to mark it up. All right. So I noticed distribution of graduates from ABC College by nationality in 2013 or 2003 and 2004. Concrete numbers matter. So I'm noticing there's 2003, 2004. There's 1 year between it. So I'm just taking note of that. I noticed that there are less students in 2023 than in 2024. So that's a positive increase, right? Then I have all of my representations here, all of my different nationalities. One thing I notice is Americans are the greatest part and Japanese are the smallest part. And I noticed that the French are the same number, right? It's the same percentage. And oftentimes that's not a coincidence. So I'm like, okay, that might be significant. Okay. That to me is all that I really kind of pick out. Does that process make sense? Does everybody kind of see how I kind of marked that up and kind of looked at that relationship and kind of skimmed it? It only took me a minute. Yeah? Okay. Cool. All right, so it says how many more French students graduated in 2004 than in 2003? So hopefully you guys know the percent change formula. We talked about it before. What is it? Wait, no, you don't have to know percent change. Never mind. But it's good to know anyway. And this, I thought it said, see, that's a good example of going back to the question stem. I thought it said the percent, but it says how many more students. But that doesn't matter, right? But if we were talking about percent change, it would be original minus new divided by original. Remember, in your sleep, original minus new divided by original. Yeah? All right. But I digress, has nothing to do with this question. Let's see if you guys can work on this one on your own, and then we'll go through it together. I don't know if you guys can hear that, but there's like a fighter jet or something like outside of my window. Anyway, it's really loud on this end. If it's loud on that end, I apologize. Okay, good. I was like, they're gonna take over. Ah, I always knew it was gonna happen. Ah. How it sounds over here. So glad you guys can't hear that. All right, let's end it. I think Joseph might have made a mistake. That's okay. Blame it on the baby. Blame it on the baby. It's always the baby's fault. Okay, let's talk about it. So immediately, what maybe one person, not sure who, maybe made a mistake and said, okay, so French students, all right, 21%, 21%, no change, 0, right? Yeah, but that's not true because remember in our markup, one of the things I immediately noticed is that there was an increase in the number of graduates from 2020, I want to keep saying 2023, 2003, it would be the same anyway, 2003 to 2004, right? So because the number of graduates change, and even though the percentage doesn't change, it still changes the value. It still has an increase in the number of students. All right, so what I can do is I can say, okay, well, 4,100 times 0.21 plus, well, no, really not plus. It would be minus, actually, I should do it the other way. 6,000 times 0.21, right? That would be the number of French students in 2004 minus 4,800 students times 0.21. That would give me the number of students in 2003. And if I subtract the two of those, that should give me the distance, right? Okay, cool. So we're on the same page there. Now, you could do this mathematically. You absolutely could. But immediately I recognize common values here. So what I want to do is combine like terms. I'm going to say 0.21, 6,000 minus 4,800, right? And I feel like I can say, okay, well, first let's reduce that. So 6,000 minus 4,800 is 1,200. All right, now I'm there. Now, instead of looking at 21%, I'm going to say, well, that's pretty close to 20%. It's about, right? So if I say 0.2 times 1,200, that makes my math so much easier. And that equals 240. But I know that number is a little low, right? Because I reduced the percentage by just a little bit. But I can still use that, and I know that it has to be, the answer has to be a little greater than or somewhat greater than 240. Lucky for me, that allows me to rule out everything but E. Okay, now you guys might have done this differently, but to me, that's just the quickest way. Okay. That's the quickest way. All right. One more question to do. It says, what was the percent decrease in the number of Japanese graduates from 2003 to 2004? All right, be really careful with this one. Be sure that you're reading the question. Be sure that you're, answering what the question is asking. All right, go for it. All right, maybe 30 more seconds, 40 more seconds. All right. Most of you've got your answer in. So I'm gonna end the poll and I'm gonna share the results. All right, let's talk about it. Most of you got it right. Well, let's still talk about it. This is what is the percent decrease in the number of Japanese graduates from 2003 to 2004. I'll never get it right. So here are percentages, right? So if anybody said 2, then I'm assuming you just said, okay, well, 10 minus 8 is 2. And can't do that. If you said 0.2, you might have said, well, it's 2% difference. So 0.2, I'm not sure what you did there. Not sure. But I understand the C. I'm not sure about the B. But let's just talk about it. Let's kind of walk through it. So we can't just subtract the percentages. We can't do that for multiple reasons. But one of them being, remember, same as the last question, there's a difference in the number of students. So because there's a difference in the number of students, we can't just subtract the percentages. That's one reason, okay? So we have to do some math. We've got to look at it. So how many Japanese students were there in 2004? Well, there's 6,000 total graduates, and 8% of that, which is 0.08, right? I can do that in my mind because I say, well, 10% of 6,000 is 600 and 8 times 6 is 48. Yes, 4,800. So I can say, okay, well, that's 48, 480. That's what I meant. I could do mental math, but let me show you what I was doing. So 6,000 times 10% is 600, and that's really close. So that tells me it's going to be in the 600 range. But then 6 times 8 is 48. And then all I have to do is add the 0. Okay. Yeah. I see what you did. Okay, I see that. Yep. Okay. And then you take how many were in 2003 here. 6,000 times 10%. Very easy, no math. That's, no, sorry. Ugh. Clearly, I need to go to bed. Let me try that again. Okay, there went all my math. Didn't mean to do that. All right, so I won't do all the math again, but we said 2004 was 6,000 times 0.08, and we determined that was 480. I did it mentally. If you can't do that mentally or if that doesn't come naturally, please feel free to use your calculator. And then in 2003, there were 4,800 students total times 1.0, and that's 4,800. So there was no change. There was no change. And I got someone who told me how they got B, and that makes sense. What they did was they said, okay, well, remember original minus new divided by original. I'm guessing that's what you said you did. And then that was 1/5, and that's how you got 0.2. And that makes sense. But remember, when we're talking about new minus original divided, new minus original divided by original, those are actual data. We can't do that with percentage points. Okay. And it's quite possible that some of you might have done that with your, you might have done that. Maybe somebody did that and got 0.2 divided by point, and then from there got 20. Maybe that was it. Okay, and that makes sense. That mistake makes sense, complete sense. But you have to have the actual quantities. So what we could have done, if these were opposite numbers, let's say this was 50 and 500 and this was 480, then we could have said 500 minus 480 divided by, well, really it would be 480 minus 500 divided by 500. 480. Because 480 would have been mine. Shoot, the other way. Sorry, I wasn't looking at my dates. Now I'm making the mistake I told you guys not to make. So let's go back and see what I mean. Let's see if I can make some more sense and stop talking jibber jabber. All right, let's start over with that explanation. Let's say that instead of 2004 being 480, again, let's say it's 500. Then we could have taken that and said, okay, the new is 500 minus the original, which is 480, divided by the original, which is 480. Okay, and then you could have calculated a percent change. But because the values were the same, I didn't have to do any math because all it would have been was 480 minus 480 over 480. Okay. Okay, good, good. Everyone's making sense. Questions? None? Okay. Well, we have some questions we didn't get to, so I'm going to go back and let you guys work through those just to reinforce some of those earlier concepts. and making sure we're all on the same page. And then guess what? We might end at least on time, but maybe even a little early again. All right, so let me go back to some questions we didn't do. All right, it says in a school outing with adults and children, the average weight of adults is 60 kilograms and the average weight of the children is 24 kg. If the average weight of everyone on the school outing is 30 kilograms, what is the ratio of students, of adults to children in this outing? All right, so we have two different concepts coming into play here. We have weighted averages. We have a little bit of ratios. So work through it. Tell me what you get. Okay, for those of us who have questions, let me at least set up the formula for you. Okay, so remember our example this one, right? When we had averages and you took that and you divided it by your, so it's all of your sums divided by your variable, right? And the number of variables. So for average weight, the first thing is you have 60 and you have 24. So let's say we have 60 and let's call it A for adults. That just helps us remember. And then we have 24 C for children. And we divide that by what? Careful. Careful. Thank you. Good. Be careful with that. I think that's something that a lot of you guys have chosen to look at the kilograms or the weighted part or whatever the actual values are instead of the number of values. So it's not the value, it's the number of the actual quantitative, like 1, 2, 3, 4, 5, 6. So if you were to say 84, that would be 60 plus 24, right? That's where you're getting 84 from, but that's the weight. But we're looking for, remember, the bottom number is the number of numbers or variables in your set. So that would be the number of adults and the number of children, or plus the number of children. So to Joseph's point here, that would be A plus C. Okay, so be careful about that. And then the next thing I can help you with is the fact that that equals what? 30. Okay. I want to relaunch this poll because nobody got it right. So I want to see if starting there helps someone get it right. I'm going to relaunch the poll and see if that piece of math helps. The next hint I'll tell you is you can use elimination. When you finish, you'll have two formulas or two equations. You'll have two systems of equations, and you can use the elimination principle or system or process to find your answer. So I don't know if you guys remember elimination. It's like, just in case, it's like if you had like x plus 3y equals 10, and you had 4x plus 6y equals 28, and you wanted to get rid of x, you could multiply this whole thing, for example, by -4, and then say -4 minus 12y equals -40. And that allows you to cancel out your x to solve for y, or your y to solve for x if you wanted, if you needed the other value the other way around. All right. Yay, whoever just answered got it right. Is this because we're lost? Would anybody like me to continue to help you work through it? Because I'm concerned. Okay, let's work through it because I don't see any more answers coming through. Okay, let's talk about it. So what I'm going to do is I'm going to keep working. Let me know, stop me. We have time. Let me know if there's a step that doesn't make sense. Okay, so the very first thing I want to do is I want to get it to where I don't have a denominator. So that means, oops. So that means I'm going to take this and I'm going to multiply both sides by a plus c. And that allows me to eliminate. So now I have 60a plus 24c equals 30a plus 30c, right? Okay. I'm going to change my pen color. Did we all get there? Hopefully so. All right, so now we can start eliminating. Oh boy, and I even told you you could use elimination here, and you can't. I'm sorry, I was looking at my paper that I've already worked this out on, and I was looking at a completely different question. So this, if that threw you off, that's my fault. I'm sorry. Okay, So let's just work through the problem. All right, so negative 30a, negative 30a, right? That gives me 30a plus 24c equals 30c. And I don't like negatives, so I'm going to take 24c and subtract it on both sides. And I'm going to take my math over here, and that gives me 30a equals 6c. Did everyone get here? Oh, well, in the next part's super easy. Your ratios already, I'm sorry, Katie, I messed you up. I'm sorry. On my paper, they look it looks like it's flowing from one to another, and it's not. It's literally the next question. So I apologize on that. Okay, so with this, if you got 30a equals 36c, then here are your ratio numbers. So that's, and you want your ratio, it's going to be 6 over 30, right? Which is 1 over 5. Right? You could also have just divided by 6 on each side, and that still would have given you 1/5. Okay. You guys are quiet. I don't know if that's like, okay. Or if that's like, what the what? Makes sense. Okay. Awesome. Looks like I'm the one that confused you guys, and I'm sorry. I'm so sorry. Okay. Let's see. Why don't I actually give you the question that is an elimination question? Okay. So here's your question, and you can use elimination on this one. So I know somebody who will get it right. Don't spin your wheels for long, guys. Because we are winding up on our time. So if you need me to give you a little hint, just type hint or can you help? And I'm happy to get you guys started if you're having trouble getting started. Okay, it's been about a couple of minutes and I don't have any answers in. So, hint, anybody? Okay, let's work through it. Okay, Sean, keep working. Okay, let's work on this, guys, because there's a couple of people who are not getting the right formulas. So let's look at it. Let me at least set you up with your formulas. Oh, that's okay, Sean. You got it the second time. That's good. All right. So what is the formula for average? So for our first formula, we'll have x plus y plus 15 divided by what? What's in my numerator, in my denominator? 3. Good. And that is or equals 9. All right. My other formula I have is x plus 2y plus 2, right? Divided by 3 equals 7. Right. So now I can get some things eliminated. And that gives me x plus y plus 15 equals 27. And that gives me x plus 2y plus 2 equals 21. That's clear. Okay. So this reminds me of systems of equations. So let me stack my formulas. I'm going to take this and I'm going to say x plus 2y plus 2 equals 21, right? Now I've got my formulas stacked. Oh, we missed a step. That's okay. All right. And remember, I'm solving for y, not x. That's important. So I'm going back. I'm saying, okay, I'm not solving for x. I'm solving for y. So that means I want to get rid of x. And because this is a smaller number, like this on this end, and I just don't like working with negatives, it really doesn't matter which one you use. I'm going to multiply this one by -1. Okay. And so on this side, that gives me negative x minus 2y minus 2 equals -21. And this, I'm going to pull this formula down here. This gives me x plus y plus 15. It's just the same thing. I'm just recopying it. 27. It's not letting me draw a line. Okay. It doesn't like that. Maybe it's too low. All right. Let me rewrite this, y'all. Sorry. It wouldn't let me write down that low. X plus y plus 15. 27. All right, now I get rid of my x. And I have negative y, right, plus 13 equals 6. Minus 13, look, I did all that to get rid of negatives and it did me no good. That means negative y equals -7. That means y equals 7. And so 7 is the answer. Does that make sense? I know some of us kind of got lost in the mix, but now that you see the math, does it make sense? You set it up wrong. Okay, it makes sense now. Good. Awesome. All right. For completion's sake, I do have one last question I skipped. And I'm just somebody who likes to get it all done. So I'm just going to at least show you guys this one question. Yeah. All right. It says the spinner has red, blue, and yellow spaces, and you have the probability for each one. What is probability? Yes, Christina, when you're doing elimination, you're always adding them together. So you're going to make one of your variables something that when you add those two variables together, it eliminates it, hence the word elimination. But yeah, it's always going to be not multiplication, addition. Okay, so what does probability always add up to? What number? Yep, 100% or 1, right? So this plus this must equal 1. That means x over 10 plus x over 5 plus 1 over 10 must equal 1. I find common denominators by multiplying this by 2. And that gives me x over 10 plus 2x over 10 plus 1. Now I have equals 1. Now I have my common denominator, so I can say 3x, right? 3x plus 1 over 10 equals 1. Multiply each side by 10, and that gives me 3x plus 1 equals 10. Subtract 1 from both sides. 3x equals 9. That means x equals 3. Does that make sense? That was an easy one. So I just kind of wanted to run through the math, make sure we've got all the kinks out when it comes to probability. You might have seen that question before. Yep, you might have. All right. Final takeaways. Know and understand your key statistical concepts, your main ones being mean, median, range, mode, a couple of standard deviation questions you may have in there. But those 4, range, median, mean, mode, 100% gonna see on the test. So make sure you understand and you know those concepts really, really well. Be really careful, guys, with that denominator and making sure you realize that it's the number of values and not the actual measurement within those values. Whenever you can, use your logic over formulas. Most of the time you can. Sometimes you do need the formulas. And don't get pressured, guys. If the logic doesn't come easily to you or doesn't come naturally to you and you know how to solve it with the formula, go with your instinct, especially after you've practiced time and time again. Just trust your gut, okay? When combining probabilities, if you see the word and, that means multiply. When you see the word or, that means add. And approach your data interpretation graphics like you do your RC passages. You mark them up, you interpret it, do your skim, summarize as you go, and then skim for those keywords in the specific questions. And invest time in avoiding those question traps, things that try to trick you up, like that whole percent of French thing, 21%, 21%. Some of us fell right into that trap and assumed it would be 0, okay? So just be really careful, or that like Japanese with the 10% and 8%. So just be careful, guys, on that one. Process one piece of information at a time and always check back to make sure you answered the question. Some things we didn't cover today related to statistics and data interpretation or counting and certain word problems that you may see. In the whole course. So something we didn't cover in the whole course, not specifically related to statistics and data interpretation. In general math, GRE math, is we didn't talk a lot about counting or word problems, but these are going to be questions that are very few and far between on the test. So we had to kind of make sure that we covered the biggest portion of the test just to help you improve your score the most. But I highly recommend that you go in and explore those intermediate modules for word problems and counting in your Magoosh account, so you can kind of gauge how good you are with that and how much work you may need in that area, making sure you don't focus too much time on that, because like I said, it's not a huge component of the test. But definitely take a look at it, see where your strengths are there. And the reason I say intermediate is if you choose easy questions, sometimes you can trick yourself into thinking you don't know it. And if you choose really hard questions, sometimes it's not that you don't understand the concept, it's just that it's a really hard question. So if you choose that middle of the road intermediate level or module level, that'll kind of give you a mix of easy, medium, hard, and kind of give a better reflection of your knowledge of the actual topic. Couple of last things to talk about. If you haven't done a practice test throughout this course, which seems like it's most of you, 70% of you, please do it this weekend or sometime really soon. If you did one earlier in this course, or if you've done one like kind of recently, at the beginning, I do recommend you take one again. I mean, you never can take enough practice tests. And I would be interested, if I were you, in seeing, after I've done this week after week, all of this practice, all of this homework, is it showing in my score? Am I seeing certain areas of opportunity improve from last time? There will be a survey at the end of this course via Zoom. Please take it, guys. And please, when you take it, give me honest feedback. This is the first time we've run this GRE cohort. You guys are the, what is it called when you're the first class? Oh, I had the word on my, anybody know what I'm talking about? The inaugural, is it the inaugural class? Yeah, thanks, Joseph. Yeah, you guys are my inaugural class for this specific type of course. So I really am going to value and pour over your feedback. It's not so much helpful, just like, that was great. I mean, I like the compliment, but what was great about it? What did you enjoy? Or guinea pigs. Okay, that works too. Guinea pigs works too. I think inaugural sounds more regal. Let's call ourselves inaugural instead of, guinea pigs. But yes, guinea pigs too. That works as well. But yes, honest, thorough feedback, saying she sucked, she was horrible. Okay, I'm willing to take that. But tell me what I did wrong, what I can do better, or even just the course, the pace, the layout. We're definitely open to that constructive feedback. And then keep in touch, guys. Add me on LinkedIn. Here's my name. Here's the link. I guess I probably should have made that a link and like sent it to y'all, but there's my name, Brittany Stringfield. That's me. Come find me. Oh, of course. I'm glad you guys stuck with me through those classes too. Wrapping it up here, if you decide that you want some help getting into grad school, we do have some admissions courses. They're really great. We are offering 30% off for people who are here today. So take a screenshot of this particular slide if you're interested, because the code is live class, all capital letters, all one word. Let me just type it. So that is the promo code for, oh, Sean will get the discount. See, look at me, sorry. Live, yeah, live class, there we go. So you can go to the link, sign up. It's going to be, we'll help you with your personal statement. We'll help you with any questions you have about admissions. It's just a really great opportunity to network, get to know people, but also get your best chances of doing well and having the best application you can have for grad school. If you have questions, help@magoosh.com. And I guess I wanted to tell y'all my reminders again. Here they are. And I have a link to the survey just in, there we go. Just in case, I wish I could just copy and paste that without having to do that. Let me know how. All right. Just in case you guys don't get the link to the survey after the class. And last but not least, I'll miss you guys. It's so hard to say goodbye. So, but I do appreciate y'all. This has been so much fun. Great 4 weeks together. I'm so glad I got to know you guys. And I really appreciate you guys so much. Thank you so much for coming. Good luck. You guys are going to do great on the GRE. Please keep in touch. Message me on LinkedIn. I'd love to get to know you guys even more. Thank you so much for a great class. Thank you guys. Oh, thank you so much. Have a great evening. Bye.